Hi everyone, so today we are here with a new problem and the problem name is coin change. Okay, so it is a very interesting and a famous problem. Okay, so let's see what is the problem and then see how we can solve it. So in this given problem we have an array which is a coin array having different denominations, and there is also one integer which is amount. So we have to return the fewest number of coins that we need to make up that amount. Okay, and if let's suppose we don't have a required number of denomination which actually able to create that amount, in that case we have to return -1. Okay, yeah, it simply means let's suppose the amount that we want is 2, right? And the denomination we have, the total currencies we have is about 3, 4 and 5. So if these are the currencies, we are not able to get this amount, right? If we add anything or if we take one currency, we are not even able to create that amount. In that case we have to return -1. So let's take some problem and understand it. So in the first problem we have this array which is 1 to 5 and the amount is 11. So how many ways we have to create this amount 11? First we can take this one 11 times. In that case we need this one denomination 11 times, right? And in this problem each denomination is infinite, means any denomination we can take n number of times. So if the first thing is we can take one 11 times and we can get this amount. The another is we can take two 5 times and one times, then we get 11. But what we want to use the fewest number of denomination in order to create that amount, so which is 5 5 1. If we take two denomination of 5 and one denomination of 1, in that case we are able to create 11 with the help of three denominations. Similarly, let's suppose the amount we have to create is 2 and 3, and the currency, the denomination of coins we have is 2. So you can see that if we add to n number of times or two number of times or one number of times, we are not able to get this 3. In that case we have to return -1. And let's suppose if the amount is 0, in that case we don't need any coin and we can simply say the answer is 0. So you can understand this problem and try to solve this problem. But this problem is basically recursion, and we can simply understand this test case, and on that test case we can basically write some of the things. Okay, so what is the first thing here? The first thing here, that each denomination, if we talk about denomination, so each denomination is infinite. Okay, this is the one thing that we get from the problem. The next thing is that if our amount is 0, in that case we have to return 0. We don't need any denomination. The third is, let's suppose if the coin let's suppose that there are coins, and if the coin value is greater than amount, in that case we are not able to consider that coin to get that amount, because that coin is not able to give that amount. So these are something. And you know one thing, what we can do is, in recursion we can understand this like, at any point of time, let's suppose I am at this point. Okay, I am at this point. So if I take this one denomination, let me write it. Let's suppose I have 1 2 5, these are the denomination and this is the amount. Let's suppose I consider this one, right? So this is the array and this is the 11. So the first condition is, if we consider this one, then the amount left is 10, right? And if again I take, because I can take this one n number of times, and if I take this one again, the amount is 9. And similarly we can go up till 11 steps, and we can have these number of denomination 11 number of denominations to make this amount as 0, right? The another thing is, we can consider this one, or we can simply ignore this one and we can directly consider this 2. If we consider this 2, then we have 1 2 5 and there is 9, right? And if we consider this 5 not 2, in that case we have 1 2 5 and 11 minus 5 is 6, right? But you can see that in each point of time there is a very huge big tree which is created here, but there are a lot of sub problems. There are a lot of sub problems that we can basically store and use it. What are those sub problems? Those sub problems, as you can see this, right? You can see 1259. In that we actually solve it and we come to know how many denominations, minimum denominations, we get from this subtree. Similarly 1259 is there also, right? And if we save this subproblem solution, then we can directly use it here, right? What are the things that we have to consider when we apply this algorithm? So let's understand those things. The first thing is if at any point of time my amount is equal to 0, in that case we have to return, right? The second important thing is the coin which we the denomination of coin which we try to consider, if that coin value is greater than equal to the amount, right? In that case we can't able to consider that amount. In that case we have to go for next coin. Okay, so there are two cases. The first is happy case. And what is happy case? Happy case is there is a coin and there is a amount. In that case the coin value should be less than or equal to the amount. So the amount we need, if the coin value is less than equal to, then we have two things. What are those two things? First, we can consider that coin, right, and number of times. And the second thing is not consider. We not consider this point. Then also we get the answer, right? And what is the unhappy case or sad case, we can say? So sad case is when we have a coin and the coin value is greater than amount. In that case we can only do one thing, which is not consider and go for next coin, right? So if we try this recursion, it works totally fine, but here we get the TLE error, right? Because at each point of time we have to explore all those things. So it is basically a very high we get TLE error due to high time complexity. Then how we can solve it? The first is memoization. We can simply use memoization, and in memoization what we can do, we can simply use a DP. DP is nothing but a matrix, or we can say it is just a data structure. We can use any data structure to store the sub problem solution, and we can store it whenever we encounter it again. The another efficient method is top down DP. So what we do in the top down DP, we basically have a matrix, right? And in that matrix what we do, we basically iterate top to down. Okay, so we basically iterate top to down, and while iterating from top to down we are filling the values. Okay, and let's suppose when we are trying to find the value for this cell, we basically use the previous solutions that we have and fill up these values. In that case what we do, we basically have a coin array, and that coin array becomes the row, and the another is amount, that becomes the column for us. Let's suppose this is 0 1 2 3 and 4, and let's suppose we have 4 coins, and let's suppose here we have 0 to 12 and the amount is 11. In that case we are initialize our table with some values. And how we can initialize? As we know, whenever amount is equal to the 0, in that case the answer should be 0, which is definite, and we can simply put 0 in that column. right? And also if there is no coin in there and if the amount is zero, then also answer is zero. And in that way we can simply solve it by using the above concept. So first let's understand how we can code this, and from there how we can code the top down. Let's come to the coding section now. So now you can see, let me open it. The first thing is this is the main function that we have coin and amount. This is the coin, and zero is nothing but index, and this zero signifies how many denomination we consider. So let's suppose if we are out of bound or we are out of this array, then we have to return the maximum size. Why maximum size? I will explain. Other than that, if amount is equal to 0, in that case whatever the temporary answer means number of denomination we have, we can simply return. And there are two cases. First is happy case, the another is unhappy case. In the happy case, what we have I as a coin, and we can consider this coin, and if we consider this coin, it means our amount is reduced, right? And we also add that we add one denomination, right? And the another is not considered. In that case, if we not consider, it means the amount should be same, and also the denomination is same, but only thing changes, the we move to the next coin, right? And similarly in the NAP case, it means we are not considering any amount, and we simply move to the next coin. Why we are passing the returning the maximum value? Because from these two things, whatever the minimum value we get, that we have to return, right? So that's why we are passing the maximum value. This gives TLE error. For that we use the same thing, but we use DP here. So as you know, this is the DP. This is the same matrix as equal to the length of coin and sums. So here the sum signifies the amount and coin signifies the coin array. In that case, we are initializing the first column. As I tell you, the first column specifies that amount equal to 0, and if it amount equal to 0, then answer should be 0. That is what we do here. And here basically for each coin, I is coin and j is the amount. Okay, and let's suppose why we do I minus 1, because we are starting from 1, but to access the value from the array is 0 based index. In that case we have to do I minus 1. So let's suppose if I is 1, I minus 1 signifies the first coin. Got it? Okay. Now, and j is basically the amount. So let's suppose amount is 11, so we are basically moved from 1 to 11. So we basically check for each what is the answer. If you want to understand more about it, you can go to my YouTube channel and see the DP masterclass, where I explain everything in the depth. Okay, but for now, simple. This is a happy case. If my coin value is less than or equal to my amount, it means what we can do. We can simply consider that denomination, which is 1 plus whatever the denomination required for the remaining amount. Let's suppose we have 10 as an amount, and the I is basically the denomination is 2. So when we do 11 minus 2, it is 9. In that case, whatever the denomination required for amount 9, we will add this. It is stored somewhere in the DP, because in the top down we are solving the upper cells, because we are solving these cells, and when we reach here we can simply use above cells value. And similarly in the unhappy case, we simply consider the I minus 1 means the next coin. And let's suppose if at the last cell we have the solution, and at last if we have the solution which is equal to the maximum size that we initialize starting. If it is equal to that, we have to return -1. Otherwise, whatever the solution which is stored in it, we have to return it. I hope you get it, but in order to understand more about DP, you can go through my masterclass. Otherwise, you can comment out. I can create more videos for you. Thank you.